In this video, we're going to be talking about an extension to loops, which is break and continue keywords. So before we talk about these, it's important to understand that iteration, looping, is kind of complicated. You have to understand when does the loop occur, how often does it occur, what's happening in the loop, what needs to be true before the loop happens, what will be true after the loop happens. Loops are already kind of complicated things. The tool that I'm going to be teaching you now, break and continue, these are things that should be used very sparingly because they make understanding a loop much more complicated. However, there are circumstances where break and continue make for a simpler solution. I just want to warn you that, once again, beginners often overuse these tools. And so in general, if you can avoid using them, great. Until you realize, oh, this is a really hard loop to write. You know what? A break or a continue here will make things a lot simpler. But I'm going to teach you those tools, and over time you'll learn when they're useful to help you write simpler code. What break and continue are non-local exits. They're basically, normally, the way that you end an iteration of a loop is when you reach the bottom of it. When you reach the bottom, you go back to the conditional, and then you decide whether you run through the whole thing again. However, there may be times when you're halfway through an iteration and you're like, you know what? I don't want to run any of the code below. Then you would break. Or you might go, I don't want to run any of the code below, but I want to continue with another iteration. Then you would use continue. So what break does is it exits the nearest enclosing loop. So if you have a break within a for loop, it will finish that for loop. It will just say, okay, when I run this statement, the rest of the for loop, we're done. It's just like if the for loop had ended there. You don't get any more iterations. You don't run any of the code below inside that body of the for loop. Same thing that happens in a while loop. And now the other thing to note is that if you're in like nested loops, if you have a for loop within a for loop within a for loop, the break will only break out of the innermost for loop. It'll end that loop, but then any other for loops in our nesting will continue as normal. If you need to break out of those, you need to set up more complicated logic. Continue is basically identical to break, except instead of exiting that for loop and ending the for loop, it just says, I'm not going to run any of the code below this. Go back up, run the update, run the conditional, and continue on as so forth. All right, so what do these look like? Well, the other thing to note is that break doesn't work in an if block. It only works in loops, like for loops and while loops and so forth. It also is in the switch statement, which will be in the next video. But break is meant to exit a particular loop. So it doesn't make sense to put a break in an if statement because there's no loops going on there. Lastly, there's one more control structure that I'm just going to put at the right here, basically because I don't want any of you to ever use it. There is something called jumps, or a go-to statement, which allows you to, when you run a particular line, to go to a particular label. I was tempted to not include this at all in the videos, but I just want to get it in here because it is one of the conditional statements. You won't ever use it in this class, and to be honest, I think I've seen only like 3 or 4 times ever in my entire usage of the C++ language did I ever see a good use of using a go-to statement. So don't ever use it, especially not in this class. Okay, so next what we're going to do is we're going to look at a couple of files that use these non-local exits effectively. Okay, here we are. We have a file. We have a whole lot of using and include statements, all of which you've seen before. So we're just going to scroll down to the more interesting part of the code. Okay, so what's going on here? We're setting up a particular variable named sum. We're setting up a variable named num. We're asking the user to enter a number and ends when the number 0 is entered. We output the number. We read in that number. Here we have a for loop. Remember, a for loop with no clauses means run forever. Now, once again, that's a really stupid idea unless you have a way to break the loop. And so we have a break right in here. So we add number to the sum. If the num is equal to 0, we break out of our loop and we don't ask the user for another number and save that in here. So the nice thing about this looping structure is it's a very simple in that we have a forever loop. I look at that and say, okay, it's going to run forever unless there's a break in sight. And there is a break in sight, and I can look at the if statement to see when that break runs. The break will only run if this if statement is true, and that if statement will be true only when number is equal to 0, which is exactly what we told the user up here. Okay, that's not so bad. And then after this break runs, we don't run any of this code, we don't loop anymore, we immediately go to the cout line right here. Okay, now what we can do is we have another use of a non-local exit. Up here, the non-local exit was break. Here is going to be continue. Continue. And what's going to happen here is we set up some doubles, we ask them for a double, and then what we do is we have a loop, and we start at 0, well, I is less than or equal to 5, we say I plus plus. If I is equal to 0, we say, hey, we can't divide by 0, and continue. What does continue mean? Continue means whatever looping structure I'm in this for loop. It means don't run the rest of the code in the body of the for loop. Go immediately to the update I, and then do the conditional. If the conditional is true, run the code again. Now this is kind of a silly example. In reality, I probably should have just started I equal to 1 instead of I equal to 0. But here I'm just once again just trying to demonstrate the use of a continue. The other thing to note is you can have nested loops. You can have nested of any of the control structures that I've talked about. Once again, these things can get kind of complicated. I recommend avoiding them if possible, but sometimes they're necessary. For instance, here we have for I equal to 0, well, I is less than or equal to 3, I plus plus, so our counter variable is I, and it's going to repeat 4 times, 0, 1, 2, and 3. And then inside this for loop, we have another for loop where j starts at 0, while less than or equal to 3 plus plus j. So j goes 0, 1, 2, 3, 4. And then we see out what I and j are, and then we once again, this is a single line for loop, and then we run the inner for loop again. So j was equal to 0, now it's equal to 1. We run that, now j is equal to 2, and then j is equal to 3. And then once j is equal to 3, then we're done with this for loop. We output an endl, and then we go and we increment I. Now I is equal to 1. I is 1, j is now 0 again, 1, 2, 1, 3, and then we're done with our loop. I gets incremented and so forth. Now, I strongly recommend using the curly brackets almost every time you write any of these looping structures. As you can see, even with the correct indentation here, it's kind of hard to read. It's kind of hard to go, oh wait, this cout is the single line of this for loop, and this cout is the second statement of this body of this block. Things get messy when you're not using brackets, but hey, we'll give you complicated code to read. Alright, so what's going on here? Here we have nested for loops. It's the same nested for loops as up above, so we don't have to spend as much time looking at it. Here we're couting what I and j are, and then we're saying if I is equal to j, we're breaking. And what break does is it says we're going to break out of our inner for loop. We're breaking out of this for loop. So then what it does is it says, okay, this loop is done. I don't care what j is anymore. We're done. And so none of this code will run. And then we'll increment I, we'll check the conditional, and we'll loop again. And let's say the next time we find j is equal to 0. What this means is that it's going to run this line, and then it's going to continue. What does continue do? It says it's end this iteration of the loop, go up to here, increment j, check if j is less than or equal to 3, and then run the code again. Now, this else here, what is this else? Well, you know what? I'm going to fix this else to make it a little bit more readable. This else belongs to the nearest if. This else will say, okay, if j is not equal to 0, this is what we're going to output. We're going to output I divided by j.